All right, guys, so remember we're talking about number sets here. You've got R resembling all real numbers. You've got Q, which resembles the rational numbers. You've got Z, which resembles the integers. And then you've got N, which represents the natural numbers. All right? Now, remember, when we put all this together, really what we've got is we've just got numbers, right? You've got real numbers such as pi and the square root of 2 and, 3 and 5 and 0. You've got fractions like 1/2, 3/7. You can add in negatives, right? We could have a -2, a -6, right? We've got all these numbers, right, that are all just numbers. Now, we also have numbers where the digits repeat, like 1/3 with 0.3 repeating, or weirder ones like 0.17634, and then the 3 and 4 repeat after that. There's even ones where you have like a set of 6 or 7 digits that repeat, and on, and we'll talk about those later. But for now, we just got these. And now all the ones I've written down so far are real numbers. You've also got imaginary numbers, which are like your square root of a negative number, or, just plain old I, right? So those are all not real. So what I want to do is just kind of look at these various things and just break it down into these 4 categories. So on the page right now, I've got numbers in general. So now what we're going to do is we're going to say, okay, well, which of these numbers is real? Well, it's real as long as it's not imaginary. So most of the numbers that we're used to dealing with, the ones that we're comfortable with, those are all real. So as long as it's not imaginary, it's real. Okay? So remember that. Real is not imaginary. Okay? Now, then we move on to Q. Now, Q, remember, was rational. Okay? So if it's rational, that means it can be written as a fraction. Now, there's a couple of ways to deal with that. You know that it's rational if it's a fraction or if it has repeating decimals. Okay? Now, pi does not repeat, so that is not rational. All right? Root 2 does not have repeating decimals. If it has a square root, unless it's a square root that you can work out pretty easily, like the square root of 4, the square root of 16, square root of 100, then in those cases, it would be irrational. You can't write it as a fraction. That's why we write it as a square root. So all of the numbers that can be written as fractions is everything except for that pi and the square root there. Negative fractions are okay. Whole numbers are okay. Negatives are okay. Even this 0.17634 with the 3-4 repeating, 3-4, 3-4, that can be written as a fraction. If the decimal repeats over and over and over again infinitely, then there's a way that you can write it as a fraction. And like I say, we'll talk about how we can figure out how to write those fractions later. Okay, so those are all rational if it has a fraction or a whole number, which could be written as a fraction, right? Because the -2 I could write as -2 over 1. It's now a fraction. So anything that can be written as a fraction is rational. Then we move on to the integers. Now, integers are rational, obviously, because you can always put it over 1. But if it's an integer, that means that it cannot be written with a decimal, or it doesn't have to be written as a fraction, right? So it's your 1, 2, 3, 4, and all the negatives of those. All right? So 0.333 would not be 1, 1/2 would not be 1, this would not be 1. Those are all rational, but they are not integers. So my integers would be this group right here. All right? And then within that, we then have the natural numbers. And the natural numbers are integers, which are positive, or depending on your definition, it could be the non-negative integers. Okay? So what you can see is that each one of these, the ones that we've described right now, is a subgroup or a small set of the numbers which we already have. All right? So you'll notice that if it's a counting number, then it's natural. Okay, it's also an integer. It's inside of the integer circle. It's also rational because I could write it as a fraction. It's also real, and it's also a number. Okay? Once we get to things that are outside of boxes, say negative 3/7, negative 3/7 is a rational number, but it's not an integer and it's not a natural number. All right? So as you go through your homework tonight, that may be something that's helpful for you to try to kind of think through, okay, is this a natural number? Start with that. Can I simplify it to a natural number? If it's a natural number, then that's what I'll label as. If I can't call it a natural number, then because there's a negative or decimal, then let's go on. Okay, well, if it's not natural, can it be an integer? Can it be rational? Is it real? And then from there, and you should be able to figure it out. Let me know if you have any questions, and we'll see you later.